All right, Intro to Cal and Statistics. Here we go. Lesson 7.8, Applications of Matrices and Determinants. So over the last couple of sections, we've been focusing on these two main topics, and here we're going to see how they apply and how we can use them. So below you'll see your objectives for the lesson. Let's get started by looking at inverses. So in 7.6, we saw how to take the inverse of a square matrix, and I told you that it was actually easier to do than the whole process out. And it's easier because we can use our determinant to help us get the matrix, or the inverse of the matrix. So up here I have our determinant for an A, B, C, D matrix, a 2 by 2, and we saw that it's just A times D minus B times C. So once you get the determinant for the inverse, it's 1 divided by the determinant. And then you multiply that by these locations. So you are literally switching the spot of your A and your D, and you're making C and B negative. So let's go ahead and try a problem. So let me write that equation out here for us so we have it on the slide. Here we have matrix A, and the inverse of matrix A is going to be 1 over the determinant, so AD minus BC, and then we're going to have that be multiplied by A and D, they switch spots, and B and C become negative. So let's go ahead and figure out our determinant first. So we take 3 times 2, and that's 6, and then we're going to subtract negative 2 times negative 1, which is a positive 2. So our determinant is 4. So for our inverse of A, we're going to have 1 over that determinant 4 in our switched up matrix. So this was position A, so the 3 goes in the bottom. Here is D, so that's going to go in the top corner. And then a negative negative 1 becomes positive, and a negative negative 2 becomes positive. So for our inverse, we're going to treat 1/4 as a scalar and do scalar multiplication. So you end up with 2/4 here, which we know just reduces to 1/2. Here you get 1 times a 4th, which is 1/4. Then it's 1/4 times 2, 2/4, which is 1/2. And 3 times a 4th, which is 3/4. So here is your inverse. So much easier than having to figure out what the inverse is when it equals our identity matrix. So you can start using this little shortcut now. Let's try another one. Here we have matrix B. You've got 3, negative 1, negative 6, and 2. So the first thing we want to do is find our determinant. So A times D is 6 minus, here you get negative 6 times negative 1 is a positive 6. So you end up subtracting, and your determinant is 0. When you get a determinant that's 0, the inverse is not possible. So therefore, b to the negative 1 is not possible. So you're done. There's no way you can calculate that out, because 0 times anything is just going to be 0. So there is no inverse. On to our next application. So area of a triangle. So go ahead and write down this formula. This is going to help us find the area of a triangle that has 3 separate vertices or points. Vertices are the corners. So these are the corners of our triangle. So you just have XY points, and they're labeled as X1, Y1, X2, Y2, and X3, Y3. So the reason we have the plus or minus sign for what the area equals is because it depends on what you get. Your area is always going to be positive. You'll never have a negative area. So if you end up with a negative and you need to make it positive, then you're going to multiply by a negative 1/2. I'll show you as we go along. So make sure you write this down. You can notice my points are right here. Here's my first point, my second point, and my third point, and then I have all ones in column 3. So let's put this to an example. here we have this lovely triangle. So beautiful. I wish it was pink. We're going to find out the area of this triangle. So we'll make this our first point. So our x1 is 1 and our y1 is 0. And then our second point, we'll have the 2 comma 2. So x, y. And we'll make this our third point, 4, 3. And then that last column is all going to be 1s. So here's our matrix. So far, so good. The next thing we want to do is take the determinant of this. So let's see. Determinant we saw, we need to, let me make some more room here. We need to copy our columns 1 and 2. So we'll do that in red. So I have 1, 2, 4, 0, 2, 3. And we're going to start by going down. Let's get a nice little highlighter. So that gives us, multiplying 1 times 2 times 1 is 2. Here you get 0 and 6. So that's the worst 0 ever. So you get 8. And then we're going to subtract our values going up being multiplied. So you get 8 plus 3 plus 0. And that gives us 8 plus 3 plus 0 is 11. So we're subtracting 11. So our determinant is -3. So what do you do with that determinant? Remember that plus or minus 1/2 that was out in front? We're going to take that and multiply it by our determinant. So are we going to use the positive 1/2 or the negative 1/2? Remember, we want our answer to be positive. Well, a negative times a negative is a positive, so let's multiply by a negative 1/2. So we get a positive 3/2. That is the area of your triangle in square units. The last thing we're going to learn is Cramer's rule. I'm not going to go into detail about how to do Cramer's rule right now, but I want you to either take a screenshot of this and print it and bring it to class, or write it down in your notebook so you have it. I'll show you how to use it tomorrow, but there's a lot of variables here and I want to make sure you have them perfectly in your notes. So in addition to copying that image and bringing it to class, we've got 2 problems I want you to try for homework tonight. The first one is going to be an inverse. So find the inverse of this 2 by 2 matrix. And of course, I want you to use the new determinant shortcut. So it's matrix A. It's 1, 2, -2, and 0. So go ahead and find the inverse of that. And of course, you can use the old method to check. And the second problem for homework is find the area of the triangle and the triangle has the following 3 vertices: -3, 5, 2, 6, and 3, -5. All right, I hope you enjoyed the video. I will see you